All right, class, so now we're going to cover section 10.2, which is all about hypothesis testing with two-way tables. These are also called chi-squared tables. Chi-square, this is chi, like the Greek letter. It looks like a fancy X. So let's look at our first example. Suppose the administrators at a college wanted to determine were concerned that there was a bias in the way degrees were awarded to men and women in different departments. They therefore collect data on the number of degrees awarded to men and women in these different departments. So this data concerns two variables, whereas previously we've been interested in one variable, now we're interested in two. And these variables are major and gender. To test whether there is bias in the awarding of degrees, the administrators ask the following question. Does the data suggest a relationship between our two variables of major and gender? So when we're working with two variables, our null hypothesis and alternate hypothesis are a little bit different. So when we have two variables, our null hypothesis is that there is no relationship between them. So in this case, our null hypothesis would be there is no relationship between major and gender. Our alternate hypothesis is that there is a relationship between the two variables. So our H sub A is there is a relationship between major and gender. So when we display our data in a two-way tables, so once we've identified our hypotheses, we want to conduct the test to see if the data supports either rejecting or not rejecting our null hypothesis. And we can display this data in a two-way table, also called a contingency table, because it displays the two variables. You've seen something similar when we were working with probabilities. So let's take a look. So this is a table of the results from a study of treatments for carpal tunnel syndrome. So there were two different treatments, splint treatment and a surgery treatment. And there was two different columns. The treatment worked or the treatment did not work. So the two-way table shows the relationship between these two variables by listing them in the rows, two variables in the rows and others in columns, okay? The entries in the cells tables are frequencies or counts. So 6 people had the surgery treatment and it was not successful, while 67 had the surgery treatment and it was successful. So the first thing we want to use this table to do is ask the following questions. So how many subjects were in the study? We're going to have to add up every number in this table. So we're going to take 60 plus 23 plus 67 plus 6. And that gives me 156. So 156 people were in this study. How many patients were treated with splints? Well, that's going to be this row right here. So I'm going to have 60 plus 23. That gives me 83. So 83 were treated with splints. How many were treated with surgery? That's this row right here. Surgery was 67 plus 6. So I have 73 people were treated with surgery. For the patients treated with splints, what was the success rate? This question is very similar to the probabilities we covered in chapter 6? Chapter 5. Okay, so for the patient treated with splints, what was the success rate? So here's splints, and here's the number of successes. Okay, so there were 60 successes out of the total number of splint treatments, which is 83. What I like to do when I'm given these contingency tables, just like when we were working with probabilities, is I like to go ahead and add up the rows and add up the columns. So I have 60 out of the number treated with splints, which is 83. So I have a success rate of 0.72 or 72%. And I want to see for the patients treated with surgery, what was the success rate? So there were 73 patients who got surgery, and 67 of them were successful. So that gives me a success rate of 0.917 or 92%. That's quite a bit of a higher success rate, don't you think? Now, to conduct the hypothesis test with a two-way table, the first thing I want to do is state the null and alternate hypothesis. Then I'm going to analyze our two-way table, determine if there is statistical significance. So we start by assuming the null hypothesis is true, so that there's no relationship between our two variables. In that case, we would expect the frequencies in the two-way table to be those that occur by pure chance. Next, we calculate the expected frequencies for each cell. Okay, so how do I calculate the expected frequency? I'm going to do quite a bit of this today, so don't worry if we don't get it so far. So our expected frequency is our row total. Remember, rows are what go horizontal, right? Times our column total over the grand total. So that's the total number of participants in the study. All right, so now let's go ahead and calculate the expected frequency for each cell in the two-way table below. So our expected frequency is our row total times our column total over our grand total. So let's go ahead and calculate our expected value for when the splint treatment, for getting the splint treatment and it being successful. So my row total here is 83. My column total is 127. And there are 156 people in this study. I like to go ahead and fill in my row totals and my column totals just to have them in a more easier to access fashion. So my expected value is my row total, which is 83, times my column total, which is 127, divided by 156. And I'm going to get 67.57. And I recommend rounding to at least 2 decimal places. So I had expected value of 67.57. Next, I'm going to calculate my expected value. Let's change colors, keep things clear. For when the treatment was not successful and you got the splint treatment. So my row total here is 83. My column total is 27. And my total for everyone in the study is 156. So I get 15.43. Next, I'm going to start with my patients who had surgery and it was successful. So let's calculate that expected value. The expected value is our row total, which is 73, times our column total, divided by 156. And that equals 59.43. I wanted to point out real quick that this is supposed to be 29. And I did calculate this correctly. I'd done them ahead of time. So if this was 29, it would still be 15.43. Sorry about that, guys. Okay, last but not least, in beautiful orange, we're going to calculate the expected value for patients who had surgery and the treatment was not successful. So I take my row total, which is 73, times my column total, which is 29, divide that by 156, and I get 13.57. It's important to note that we had 156 people in our study. So if I take all of my expected values and add them together, even though you can't have 0.43 of a person, that's okay with expected values. I'm going to get 156. I get back to our total. So that's just something I really wanted to highlight for you guys. Let's take a look and see if we did this right. Okay, so they rounded to 3 decimal places. That's okay. But here we have our observed values from our study and our expected values. Now, how do I continue to conduct this hypothesis test now that I have my observed values and expected values? We're going to compare the frequencies expected by chance, right, and the observed frequencies from the sample. We do this by calculating something called a chi-squared statistic. And it's kind of similar to the role of a t-statistic in the previous section. So using a chi-squared statistic, we're going to determine if we should reject or not reject our null hypothesis. So, how do I calculate a chi-squared statistic? Okay, so chi-squared is the sum of all values of our observed values minus our expected values squared divided by our expected values. Okay, the larger our chi-squared gets, the greater the average difference between our observed values and our expected values in this cell. And there's a nice table we can set up to help us solve this. So here's the chart I like to set up. So we have this chart. What we do first is we take our observed values. So let's say we were studying the relationship between degrees and majors. That's the same thing. Gender and major, right? This was gender and major. We take our observed values. We calculate our expected values. We then take our observed minus our expected values. It's important to note that these are always going to be the same except 2 are going to be negative and 2 are going to be positive. They should always add up to 0. We then square these to make them not negative, right? Again, these are all going to be the same, so you really only have to calculate it once. Next, we're going to take our observed minus our expected value squared. So this, right here, minus our expected value. Divided by our expected value. So 3.59 divided by 111.89 gives us this. 3.59 divided by 30.104 gives us this, and so forth. And we add this up to get our chi-squared value. So we take the sum of these 4, and that gives us 0.35. So we're going to calculate the chi-squared statistic for the data in the table below. We already found our observed value. We have our expected values, and we're going to calculate our chi-squared statistic. So let's take a look at this. So I have my observed value. I have my expected value. I'm going to take my observed value minus my expected value, and I'm going to get negative 7.57. If I take 23 minus 15.43, I'm going to get positive 7.57. If I take 67 minus 59.43, that gives me a positive 7.57. Again, this should all be the same. And then if I take 6 minus 13.57, that's going to give me a negative 7.57. And all of these will add up to 0. Now I square this. It's going to be the same value because we have the same number, and negative 3 squared is 9 and positive 3 squared is 9, and we're going to get 57.3049 for all of these. See how this table is really helpful at getting everything organized. So next I'm going to take 57.3049 divided by our expected value, not our observed value. So I take 57.3049 divided by 67.57, and I get 0.84. I take 57.3049, and I divide that by my expected value of 15.4. That gives me 3.71. If I take 57.3049 divided by 59.43, That gives me 0.96. And last, I take 57.3049 divided by my expected value, and I get 4.22. So I add these all up. I take 0.084 plus 3.71 plus 0.96 plus 4.22, and that's going to give me 9.73. So this is it. This is my chi-squared statistic. It was not as much work as we thought, right? The question is, what do I do with this now? 9.73. What do I do with this piece of information? So, how do I know whether or not to reject or not reject my null hypothesis? Is there a relationship between the treatment for carpal tunnel and the success rate? So, if our critical chi-squared value, which we have is 9.73, is less than the critical value from table 10.5, that's our next slide, then the differences between the observed and expected values are small, and there is not enough evidence to reject the null hypothesis. Okay, so we want this number to be greater than our critical value. Let's take a look. That's when we reject it. And luckily with chi-squared, unlike t-tables, we can have two different significance levels, 0.05 or 0.01. So if my chi-squared is greater than or equal to my critical value, these are our critical values, this table right here, then we can reject. I like this table because the instructions are right at the top. So nice. So we look at the size of our table. We had a 2x2 table, and I had a chi-squared statistic of 9.73. So we can reject our null hypothesis only if chi-squared is greater than my critical value. So let's look at our two critical values. Well, my chi-squared of 9.73 is greater than 6.635 and is greater than 3.841, okay? So we can reject our null hypothesis. Our null hypothesis at the 0.01 significance level. Remember, if you can use the smallest significance, you want to use the smallest significance level you can use. All right, so let's talk our way through another example. So, a study seeks to determine if vitamin C has the effect of preventing colds. So among a sample of 220 people, okay, 105 randomly selected people took vitamin C pill. Okay, so 105 out of 220 for a period of 10 weeks, and the remaining 115 people took a placebo. At the end of 10 weeks, the number of people who got colds was recorded, and we want to determine if there's a relationship between taking vitamin C and getting a cold. So how many people got colds? Well, 100 people didn't get a cold, so that means 120 did get a cold. So what we're going to do is we're going to want to calculate the expected value for each of these for each of these four squares in our table. So our observed values were 45 for vitamin C and you get a cold, okay? Are 60 for vitamin C, no cold, 75 for placebo, no cold, and 40 for placebo and no cold, okay? And we're trying to see, is there a relationship between taking vitamin C and getting a cold? We're comparing two variables. So friendly reminder that our expected value equals my row total times my column total divided by my grand total. So I'm going to take, for our first column, I'm going to take 45 plus 60. that's my row, times my column of 45 plus 70, 5, and I get 57.27. Sorry, divided by our grand total, and I get 57.27. Okay? For vitamin C and no cold, I take my row total, 45 plus 60, times my column total, divided by 220, and I get 47.37. For placebo and a cold, I get my row total, which is 75 plus 40, times my column total, which is 45 plus 75, divided by 220. That's going to give me 62.27. I'm sorry, 62.73. Can you guys hear my cat crying? I locked her out because she was making too much noise. Of my bedroom, not outside. Oh gosh. Okay, so back to math. I then take for placebo, I take my row total times my column total, all divided by 220, and that's going to give me 52.27. And friendly reminder that if I add all these up, all my expected values, I'll get back to 220. So then I take my observed value minus my expected value, and I'm going to get negative 12.27, 12.27, 12.27, and negative 12.27. Remember, all these are going to add up to 0. I'm going to square it, and that'll give me the exact same thing, 150.61 for all of these. Now what I do is I take my observed minus my expected value squared, so 150.61 divided by my expected value, which in this case was 57.27, and I get 2.63. For vitamin C and no cold, I take 150.61 divided by 47.37, and I get 3.16. I take 150.61 divided by my expected value of 62.73, and I get 2.40. And last but not least, I take my observed minus my expected value squared divided by my expected value over here, which was 52.27, and I get 2.88. Now I need to find the sum of all of these, right? This is going to be my chi-squared statistic. So I add these up, and I get 11.07. Now what does that tell me? So now I know my chi-squared statistic. I have a 2 by 2 table, so I'm going to be looking here in this row, and I can reject my null hypothesis only if my chi-squared is greater than the critical value. Well, 11.02 is greater than 6.63 and 3.81, so I reject my H naught at the, remember we're going to use the lowest significance level possible, 0.01 significance